First question. Which of the following is not an example of trivalent impurity in intrinsic semiconductor? So indium, aluminium and boron, they are trivalent. Arsenic is pentavalent. So option 2 is correct. By the way, the trivalent impurities, when added to an intrinsic semiconductor, it makes the semiconductor p-type, and when a pentavalent impurity is added to an intrinsic semiconductor, it makes it n-type. So this is an extra information. Question 2. In the Young's double slit experiment, two slits are made 1 millimeter apart and the screen is placed 1.5 meters away. What is the fringe separation when blue-green light of wavelength 500 nanometer is used? So we know that the fringe width delta y is lambda t divided by t, where t is the distance between the slits and the screen. T is the distance between the slits. Since everything is given in millimeter in the answers, it is better to use the unit millimeter everywhere. So lambda is 500, 1 nanometer is 10 to the power minus 6 millimeter, and t is 1.5 into 10 to the power 3 divided by 1. So this is 10 to the 2, this is 10 to the 3, and this is 10 to the minus 6. So the answer is 7.5 into 10 to the minus 1, that is 0.75 millimeters. Question 3. The moment of inertia of a thin circular ring with radius r with an axis along the diameter is given by. So as we know, the moment of inertia is always proportional to m times r square into a factor alpha. Alpha is a number. Here Iz is the axis passing through the center of the ring and perpendicular to the plane of the ring, and Ix, Iy are the moment of inertia about the diameter, and Iz is well known as mr square, and we know for a planar object Iz is equal to Ix plus Iy, and because of circular symmetry about the z-axis, Ix is equal to Iy. Ix is Iz by 2, that is half mr square. And from this condition, you can see that option 3 and 4 cannot be the possible answer. Question 4. A bullet of mass 0.03 kg is moving with a speed 90 meter per second, enters a heavy wooden block and is stopped after a distance 60 cm. What is the average force exerted by the block on the bullet? So the average force exerted is final momentum minus the initial momentum divided by the time of journey of the bullet. So we need to find out this time of journey. Here we can use two kinematic formula. One is v square is u square minus 2as. V is u minus at, where a is the deceleration with which the bullet is moving through the wooden block, and when it comes to rest, v becomes 0, and u and s are given as 90 meter per second and 60 centimeter. So we need to find out the t. From the first equation, a is u square by 2s, and from the second equation, t is u by a, which is u by u square into 2s, that is 2s by u. If average is final momentum is 0.03 into u divided by t, which is into 90 divided by 2, 60 into 10 to the power minus 2 into 90. The answer is 202.5 Newton. Fifth question. Which of the following quantities has dimension formula of m to the power 1, l to the power 0, t to the power minus 2? Notice here the power of l to the power 0. This is suggesting physical quantity per unit length. So now the momentum has a dimension mass times velocity, lt to the power minus 1. Kinetic energy is mass times l square t to the minus 2. Angular frequency has a dimension t to the minus 1, and surface tension is force by length. Force has a dimension mass times the dimension of acceleration divided by length, which is m to the 1, l to the 0, t to the minus 2. Option 4 is correct.